Hello guys, welcome to the channel. In this video, we are going to start a new module, which is object-oriented programming. So far, we have covered a lot of ground. We started with an introduction to Python and we learned about different data types, control flow, collections, and then recently we have learned about functions. Now we are going to take things one notch up and we will talk about object-oriented programming or OOPS. This video is dedicated completely to laying the foundation for OOPS, understanding what is OOPS. We are not going to be doing any coding, that will follow later. But the purpose of this video is to develop a very solid intuition, a very solid mental foundation for OOPS, why it is needed, and understanding some basic ideas around OOPS like class and instances, etc. And this video is also coding agnostic, like I said. So even if you're not learning Python, if you're interested in learning some other language, still this video is completely relevant to you. And this video is a part of my hands-on Python for beginners playlist. So if you're someone who's just starting out on your Python journey and you're looking for a playlist where everything is covered in a systematic way, from right from the basics up till building projects which will be industry relevant, so you can follow this playlist, and this is going to be very helpful for you. This playlist is not complete. I'm still working on it, and I'll be adding a lot more videos and projects into this. So I'll make the link for the playlist appear somewhere on the screen, or you can also find it in the description section. You will also find a link for my Discord. You can connect with me there in case you're having any doubt or if you have any suggestions regarding the playlist. With that being said, let us jump into the video and let us understand what is OOPS. So before we get started with basics of OOPS, let us spend some time building a mental foundation and intuition for what is OOPS, why it is needed, and then we will get around to some formal definitions around it. And even before that, I think it will be a good idea to do a quick recap of some of the things that we have already learned, especially the data types in Python. So if you remember, if you're following this playlist, we started with some basic data types like integer and float. Let me jot it down, like integer, float, and boolean, and string. And then we learned about some collections in Python like list, dictionary, and set, and tuple. Let us pay some attention to list. Let us take this list out and try to understand it a little bit more. I remember in the intuition video for list, we discussed a few things. I want to revisit those now in a different context. And even before we talk about lists in Python, I want you to think about lists in general, in real life. And I think I gave you this example when I was introducing lists. I told you that list can be thought of as a real life entity that was made in Python. So when I'm talking about a real life list, I'm actually referring to the list that we all make in our day to day life. For example, a playlist, or a shopping list, or maybe a study list or something, grocery list. And when we were talking about a real life list and how they're implemented in Python, I told you to think or imagine about two very key important aspect of a list. And those were characteristics and behavior. Characteristics and behavior. And I think the same idea can be extended to any other data type that we know in Python. And if you extend it further, I think it is true for everything that we know in Python. But for now, let us take example of a dictionary. Even in a dictionary, we can think of characteristics and behavior. Now, what are characteristics and what are behavior? Characteristics is something that dictionary has, for example, or maybe a list has. For example, a list will have a name, a list will have a size, a list will have maybe elements. And behavior is something that we can do with the list, or something a list can do. For example, append a list, pop a list, remove a list. Similarly, a dictionary will have its own characteristics like keys and values, size, and similarly, a dictionary will also have a behavior. For example, adding a new key or editing a new key, changing the value of a key, etc. Now, this idea or this philosophy of something having characteristics and behavior is true for everything that we have learned in Python. In fact, it is true for everything or all the objects that we even know in our real life. So, at this point of time, I want you to appreciate that there were some real life items or real life entities which somebody saw and somebody observed, and they felt the need of implementing that in a programming language. And they studied the characteristics and behavior of that object, and they invented that object within Python. Somebody must have done that. Somebody must have invented a list, or somebody must have invented a dictionary. For that matter, somebody also invented integers. Somebody also invented float, boolean. because Boolean, true or false, and conditions, these are all the things that actually exist in our real life. We always deal with conditions, we always deal with something that is true or false, we deal with strings. So if there was a need to store some text or a story in a text file, somebody had to introduce the idea of a file. Somebody had to introduce the idea of a string, and a string gets saved to a file. So everything that we know in programming, not just in Python, even if you keep extending, it is true for the entire universe, entire world. So what I am getting to is that if there were some real life entities like list and dictionary and maybe a set or integers or floats that had the requirement of being invented in Python, or somebody took that pain to invent that in Python, what are the chances that there are other real life objects that we might need to create within Python? List and dictionary are built in, it is already made available to us because it is very common and it is very widely used. Or if we are trying to solve some real life problems in Python, we might need to create other real life entities in Python. And that is where object oriented programming comes in. And the way we are going to do it is inspired by these two very key characteristics. So let us take some more example and try to see how we can create some real life entities within Python. So before we move ahead, there are few other things that I want you to think about and keep in the back of your head in order to build the intuition of where I'm getting to. So if we talk about a list, try imagining being the person who invented list in Python. So before he started using list, he would have had to design list in Python. How is the list going to behave? And for that, let us see how we actually perceive list in Python. So how do we probably make a list? Okay, so he would have had to think about how to make a list. We make a list like this. We say a is equal to 1, 2, 3, 4, and 5. Okay, so it is represented by this bracket, and there are some values, there is some index, and we can access the values using the index, we can run loops on it, all of that, right? And there are different data types, so within this list there is maybe an integer, or it could have been a string as well, right? And then he would have to think about what are the things that we can do with a list. For example, a dot append something, or a dot remove something, or a dot sort. These kind of methods he would have had to think about. So first he would have created a design. First he would have created a design. There must have been some documentation, or there must have been some blueprint that contains all of this information, that when we write a is equal to with this bracket and we enter some values with a comma separated kind of a thing, or we add strings, so then a list gets created. And once the list gets created, this a here is of the type list. When we do a type on this a, it becomes a list. And once this a is of type list, then we are allowed to access some of these methods like appending, removing, sorting, indexing, finding, etc. Right? So I want you to imagine term list as a design. This is an idea. Similarly, or an idea. Similarly, I want you to imagine dictionary as an idea. Or if you want to extend it to our real life, I can say maybe humans are also an idea. It's a design. The very term humans, it is a design. When God created humans, he must have first created a design of what humans can do and what humans will have. What are the characteristics a human will have, and what are the behavior that a human will possess, right? Similarly, if we think about phone is also an idea or a concept. You can call it an idea or a design or a concept. Once we know the concept, once we know the idea, we can manufacture that idea into a tangible entity. For example, a factory that produces phone, will first have the design of a phone, what the phone is going to look like. Once the design is present, they can manufacture a phone. So maybe one phone can be Nokia, one phone can be Apple, one phone can be Samsung. Or let us think about a real life entity called a car. So do you think before we manufacture car, or anybody who thought about car, first of all would have made the design for a car or the concept of a car? Even now when some cars get launched, we first see the concept of the car, and then the car actually gets manufactured. So in order to implement some real life entity in any programming language, or to in fact invent something anywhere, even in real life, first we need the design, and then we actually need to create it. So first we need the design, and once the design is ready, using that design we actually need to manufacture it. Okay, and anything that is manufactured using this design will be called as a car. For example, phone, there is a design of a phone or the concept of a phone, and then the phone is manufactured and somebody buys it, and then we call that phone as maybe this is Ram's phone and this is Shyam's phone. Okay, like that. Similarly, humans. Okay, there is an idea or a design of a human. We don't know who created that, but whoever created humans must have first created the idea or a design, and all the humans shared that design. And then humans started getting born. So when humans get born, we have maybe Rohan is born as a human, and Mohan is born as a human, or Sohan is born as a human. This design, let me introduce some terms now. This design or this idea, whenever we want to, please remember the ulterior motive of what we are trying to do. We are trying to create something that we know in real life into a programming language. We're trying to learn that concept. I told you that first we need to create the idea. First we need to create the idea, we need to create the design or the concept, and then we need to manufacture it. So this design or this idea in Python, we will refer to that as class. This is a class. Okay. And anything that we manufactured using that design, anything that we create using that design, for example Rohan, Mohan, Sohan, or Ram's phone, Sham's phone, okay, these are going to be called as instances or instance of a class. There is an idea, there is a broad idea or a concept, and using that concept we are manufacturing something or we are creating something, and those are called as instance. So if we go back to the example of a list, there is an idea of a list or a class list. This design actually contains everything that a list has and list can do. So this class or this design will contain characteristics and behavior. And from now on, I'm going to call these characteristics as attributes and this behavior as methods in programming terms. But what they are is characteristics and methods are behavior. Characteristics, again, something that list has. Behavior is something that a list can do. And I will implore you to think about anything that you see around you, maybe this pencil or this monitor or maybe a table, book, everything, any object will have some characteristics and it will have some behavior. And if we understand those attributes and methods or characteristics and behavior, we will be able to invent it, reinvent it, or we might be able to implement it in Python. Now I want to again reiterate the idea of class and instance of a class. So for example, we were talking about the list. So there is an idea of a list, class list, okay, and then we create the actual list. Okay, the design is not just enough. So when we create, say for example, when we say a is equal to 1 2 3, this is a list. Okay, so we have actually manufactured a list. This is called as instance of a list. This is called as instance of a list. And if you remember in some of the previous videos where we were trying to, in fact, in the second video, I think, where in the introduction to Python video, where we were getting type error. If you remember, we were getting type error, and the error message said that. Addition, yes, I think we were trying to do maybe a list a, we were trying to do a plus 10. Okay, where a was a list and 10 is an integer, and we were trying to add this. And if you remember the error message that we got, the error message that we got was addition is not possible between instances of string and integer. So this is what a is, instance of a list, okay, and 10 is instance of integer, where list and integer are actually classes. They are actually designs, or they are actually ideas. And 10 is an integer which is manufactured using that idea. Similarly, 9 is also an integer, 10 is also integer, 11 is also integer. Similarly, 1 2 3 1 3 4, this is also a list. 10 20, this is another list. So a and b are instances of list, 9 10 and 11 are instances of integer. Similarly, float, similarly dictionary, right? Now what I want to do is I want to create something new. We already have list and dictionary and everything. I want to create something new. For example, I want to create car. So what will I do? The first step is I will create the design, or I will create the class, and then I will manufacture it, or I can say create instances. If you have understood the difference between idea and instance of an idea, or class and instance of a class, I think that is the major takeaway that I'm trying to enforce in this video. Okay, because oops, or object oriented programming, is more than just learning the syntax. Up until now we were learning about list and dictionary. They were quite intuitive. Okay, and the important thing was that you remember the syntax and what are the things that we can do. But oops actually is agnostic of Python. If you're not learning Python, if you're learning maybe Java, or if you're learning C++, if you're learning any language, oops is very very important. And oops is more than syntax. It is about thinking. It is a paradigm shift in how we think. It is a different programming approach. So until now what we have been doing is procedural programming. We were writing lines of code one by one and executing them one by one. We are saying a is equal to 10, b is equal to 5, a plus b, a minus b, right? And then we got down to functions, which is one layer of modularity. Now what we are doing is object oriented programming. It is one step above of functions. Here we are trying to imagine things in not a procedural way. We're trying to imagine things as objects and how those objects interact with each other. Let us come back to the example that I was giving about a car. So I want to manufacture this car. So first I will create the design and then I will manufacture it. So how am I going to create a design? So I'm going to create a class car. Okay. And in this class, what are the things that I need to have? Yes, you guessed it right. We need characteristics, or now I'm going to call it attributes. And then I'm going to need some methods. And it is up to us what attributes or what methods we want to impart to car, depending on our use, depending on our need. So for example, I can have an attribute which will be maybe name of the car, and I want to have the brand, have type. Okay. Similarly, in terms of method, for a car, I want to have drive. A car can drive, and a car can brake, and a car will park. These are the three things that I want to have in this car. So here I have created a design of a car or a blueprint of a car, and this is called as a class of the car. Now, once I've created this design, it is time for me to actually manufacture a car. So maybe I'm going to manufacture two cars. I'm going to say this is my car 1, and this car will have a name. So for example, name will be Creta, brand will be Hyundai, and type will be SUV. And similarly, it will have some methods, so driving, braking, parking, etc. Now how car 1 is going to park, or how car 1 is going to brake, and how car 1 is going to drive, that is up to us to decide. We'll see that later. Similarly, I'm going to manufacture another car which will be based again on this design. Okay, this car is car 2. Okay, and this car is maybe city, name is city, brand is Honda, and type is sedan. And this will also drive, and this will also brake, and this will also park. Similarly, I can keep creating different cars. Now what will be the type of these cars? Type will be car. Just like earlier we used to have type float, type string, type list, the type will be car. So how are we going to create it? We are going to say maybe like this. If you remember, we used to create a list like this. A is equal to, we could have created, we don't usually use this syntax, but we can create a list like this. We can say 1 2 3. So similarly, now we are going to create a car. We are going to say car 1. Car 1 will be belonging to class car, because I wrote it in capital letters. So I'm using car. And then we are going to give some name of the car, or whatever data we need to make this car. Okay. And this car 1, if you do a type on this car 1, I will expect for it to have a data type called car. So what have we done? We have created a new data type. We have created a new custom data type that is needed for our requirement. Now you might ask why we are doing all of this. Of course, we understood that object oriented programming is all about creating real life entities in Python. How are we going to do that? We will do that by creating a design, and then we are going to manufacture it. What is there that is going to make up the design? The attributes and methods are going to make up the design. Once we have the design, we will create instances of the design. For example, this car is the class here, or this is the design, and car 1 and car 2 are instances of the class car. So these are instances of car. Fine, we have understood all of this, but why are we doing this? What is the need, or what is the requirement? Okay, so need and requirement for this is something that I don't want to get into right now. As in how we learn object oriented programming, I think it will come to you that why we are doing this. But I'll give you a small starting idea of why we are doing this. Say for example, we want to build a library management system. We want to build a software for a library management system, or we want to build maybe a school admission system, or we want to build a social networking site like maybe Facebook. So if you think about any of these problems that might need a programming solution, let us take a library management system. What are the things that you need to build a library management system? In order to build a library management system, you will build a software. You're going to sell that software to somebody. Okay, a person is owning library 1, he will use your software. A person who is owning library 2, he is also going to use your system. So first, in the system, you need to create a library. Library is something that does not exist in Python. So you need to create library. In order to create the library, you need to create the design of library, and then you need to specify what are the methods and attributes of a library. Once you have created that design, then you can sell it to different people. A person owning library 1 is going to use your software. He's going to create his library. So he's going to create maybe library 1, lib 1. Okay. In library, what are the things? A library will have a librarian. So you need to create a librarian also. A librarian will further have a name. A librarian will have a age. Librarian will have gender. And a library will also have books. Now, how are you going to manage books? Books don't exist in Python. So we need to create books. So again, we'll create the design for books, and then we are going to manufacture some books. Again, books will have some methods and some attributes. What are the characteristics of a book? Name of the book, title of the book, number of the pages, who is the writer, who is the publishing. And then there are some things that we can do with the book. For example, we can give a book to a customer. Now again, we don't have a customer, we need to create a customer. And then a customer is again going to have a name, customer is going to have a age, customer is going to have a gender. Now librarian and customer, they have something in common. For example, they are both going to be human beings. There are students who are going to come to library, to maybe a library is associated with a school or a college. Okay, so we have to create a school or a college again. The idea of money, maybe. And a library or a school or a college will also have an address. Again, address does not exist in Python. We need to have an address also. We need to create an address. Address will again have some methods and some attributes. So you see, we need to create the entire universe in order to solve this problem. And all of these are going to be created using object oriented programming. Now, is object oriented programming needed all the time? No. And in fact, it is optional. In fact, I want to say something that you might not believe I'm saying, but as a data scientist or as a machine learning engineer, you may not even need object oriented programming. May not need. There are a lot of people who don't know object oriented programming, who are actually working in industry. That is completely fine. But in order to be a good software developer, in order to be a good data scientist, or someone who actually understands things that is going behind the scenes, I strongly recommend for you to actually learn OOPS. Even if you're not a master of OOPS, at least you should know what is OOPS, so that you can at least write good code and understand good code that has been written by other people. But it is actually optional. It is not needed all the time. For example, if you don't know about list or dictionary, it is very, very difficult for you to operate. But if you don't know OOPS, you might survive. You might write code without using OOPS paradigm, but that code will not be as good in given situations. Certain situations actually don't need OOPS. Okay, so again, I'm saying this is optional. This is a tool in your kit bag that is going to make you a very, very good software developer. And again, I'm saying OOPS is little bit less about the syntax and programming. It is more of a way how you think, how you perceive things. It's more about perception, and it takes a little bit of time to start seeing things in the perspective of class and objects. Okay, so take some time. That's why I created a special separate video where I try to develop intuition behind what is an idea, what is the instance of an idea, what is a class, what is a method, what is the attribute. And in the coming lectures, we will do a little bit of practical. Okay, and maybe after 2 or 3 videos you will get some practical understanding, and you will start writing your own class and methods. And after some time, when you actually get a real life problem, you will start to think of that problem in terms of OOPS paradigm or OOPS programming approach. So in the next video, we will do practical of OOPS. We'll see how we create classes, how we create instances of the classes, and how do we attach methods and attributes, and how we instantiate a class, and different aspects of syntax of OOPS in Python. Mentally, I would request you to constantly keep thinking about OOPS whenever you're doing anything else. If you're learning any other library, keep thinking about the person who must have designed it and what are the methods and attributes he imparted to it. Okay, and if you got a chance to create your own object in Python, okay, it's your imagination. Try to imagine anything, maybe a keyboard or a computer or maybe a human being, a friend, right? And at the same time, parallelly, you are going to be working on the syntax of object oriented programming in Python, and we are going to take a lot of examples. My approach would be to apply OOPS to as many different practical scenarios as possible, so that you can start probably becoming a little bit more comfortable with OOPS. And once we have done that, I'm planning to have a small practice project. It will not be like an industry project, but it will be project where we will try to take a complete real life scenario and try to build it in Python. Maybe I will think of a library management system, or maybe a banking system, ATM system, or a social networking system, something. And we'll see how different concepts of OOPS are coming together. Once we have done that, and once we have gotten hold of basics of OOPS, which is class methods, static methods, instance methods, etc. Once we have done that, then we will move ahead and we'll learn slightly advanced concept of OOPs like inheritance, polymorphism, and method overwriting, duck typing, etc. Okay, and that is where we will conclude OOPs, and then we will do one more project which will include everything about OOPs. So I'm planning to do two projects, one with just the basic of OOPs. If you learn up till there, that itself should be sufficient. But if you are interested, if you develop interest in OOPs, you can learn ahead about polymorphism, inheritance, etc., and do one more project. Okay, if you do that, I promise you, it will make you more confident, and you will feel that you have the way you think about programming will change. Okay, if you learn about OOPs. So that is all that I wanted to do in this video. I hope I was able to build a mental foundation, a solid intuition of what is object oriented programming, and we'll continue this idea further in the next. If you're new to this channel, this video is part of a hands-on beginners playlist, and if you want to learn some other topic of Python, especially a beginner oriented, project oriented, example oriented videos, please do check out the playlist. I'll make it appear somewhere on the screen or in the description section. You can also connect with me on Discord. The link will be in the description. If you have any questions, or if you have any doubts, or if you want to request any certain concept that I cover in this channel, you can connect with me there personally, and I'll see you in the next video. Thank you.